As Pierre mentioned, I'm gonna talk about some experiences that we have in the Mexican industry. An interesting issue that was expressed in the previous presentation is that we need a lot of data. We are talk about a little bit. We talk a little bit about it, but from other perspective. I mean, from the perspective that we have see several very often problems opposite to that situation. That means there is not too much data. So we are going to talk a little bit about it, and I hope that you can find interesting this talk. So the overview of the talk is the main 3 points. The first is I'm going to talk about the problems with data sets in the Mexican industry. I assume that there are other industry in other countries that could have a similar situation. Then I'm going to explain what was the case study that I developed. Currently, this case study is right down in a paper, but only this presentation is only considering one part of that. And in the third point, I'm going to show the results in 3 case studies that we developed. Okay. The point 2 is the structure of the case study. I mean the how it was organized, and the point 3 is the application of that case study. So let's start then. I'm going to begin with the estimation basics. So related to software, we need to get product requirements. When we get the product requirements, we understand that we can have a measure of that product requirements and identify the product size. And if we have enough data, we can get or we can construct a database with a lot of projects or several projects, considering the product size and trying to find a correlation with effort or cost or maybe duration, and it's a little bit more difficult with the duration. So if we get enough information to construct this database, we can get an estimation with project effort. So considering this situation that is very normal, I am only put it here in as an assumption, as we can move then to the other slide. In this slide, we understand, or we are saying as other authors, that the measure of the size of the piece of the software is a relevant factor in the estimations. So there is other authors that mentioned that, and we have been developed in Mexico a baseline study about cost and productivity for the Mexican software industry. The last year, we present a talk in the ISBSG 2020 when we compare some studies that we developed with the data in Mexico against the data with the ISBSG, and and I show that the behavior is pretty similar. So in this study that is sponsorship by the Software Metrics Association, Mexican Software Metrics Association, we identify or we corroborate that the functional size is the variable with more impact in the estimation of cost or effort. So this is in Spanish, but functional size in Cosmic is about the 75 impact determination coefficient from other variables. The other variables are certification in quality model, main principal language, specific sector for the organization, main database, size of the organization, type of development. I mean, it's a new development, maintenance, or something like that. Operative system and architecture. So we corroborate that the functional size is the main factor. Considering this situation, the goal is to generate or to create a reference database or a database or estimation database. The most of the models that have been developed in the literature, we can observe that are dependent of the representativeness of the samples. That means depending of the data is the results that we're gonna get with the model. Morgenstern point out that to generate estimation models, we need data, as we have been mentioned, but most of the organizations do not have this data. So generate data implies some expensive and time consuming. There is Abraham mentioned that also the most of what is called estimation models now are in reality productivity models. What is it means? That these models represent the past behavior of the projects in that organization, considering all the variables involved in that. So what is happening, or what is seen in the literature, is that most of the researchers that have been developed or using estimation models, they are constructing their databases with past projects in which they participated. So that information first is not available for all the people, is difficult to acquire, and some information does not make sense for all the people. This point is important about the goal of the ISBSG and some other organizations like the Software Metrics Association and the other metrics associations around the world, because you can put available to the people some information that is could be considered open information for all the people. So it's different because this information is related to the real projects, most of them, and not only as academic projects. This is an important issue. For example, Braga mentioned that that the authors, I mean Braga et al., do not found any reliable information about the way how or which projects are included in how the projects that are included in the data set were obtained. So this is an important issue. Also, Carbonera analyzed the number of in the literature the databases, and they classify in three classes: high quality, medium quality, and low quality. Considering the high quality, a data sets with more than 15 points, medium quality with 10 to 15 data points, on low quality, less of data points. This is an important highlight because what we see here is that the databases usually have low data. I mean, even with the high quality that Carbonera identified in 2020, more than 15 points, more than 50 points, they are here not mentioned a lot of data. I mean, huge quantity of data, while the lack of data set with high number of data is a main statistical principle. So most of the data sets contain small quantity of data. I understand that there is some specific organizations that more mature organizations, or that have been that have get close to some professional companies. Maybe they get more data, but usually the data sets are not so big. Another issue that found Carbonera is that students or researchers are the more common participants in the primary studies where use data sets. So this is again an important element, because when we are trying to make consultancy or trying to solve problems in the industry, most of the projects are or present a different behavior. So these are some problems with data sets that we usually have and that they are documented in the literature. However, from the perspective from the real perspective in the industry, what we have been shown, or what we have been observed, sorry, we have been observed that related to the databases, usually the organizations have absence of databases, sorry, using a functional size method to correlate effort or cost. I mean, they are not using usually any functional size method. If they are not using any functional size method to generate their data sets, they are not using any standardized metric. So this is an important and main issue. As previous, we mentioned that the main statistical principle is that we have a lot or enough data to generate estimation models or make yes, we have a main statistical principle is that we get a lot of data to generate estimation models. The absence of the use of functional software size method is lack of metrology. That means we are not using any standardized metric that could be compared the projects in a same database or with another databases. So this is a main problem we have identified. And the other problem that we identified is that the organizations understand that the effort or cost required to generate a database is required. Two they are not necessary or not always are able to pay for that. Okay, so these two problems are very often present in the industry, at least in Mexico. We have observed in more than 12 years of the same situation. Maybe it could be because we are in the mature process to adopt functional size measurement methods. I don't know, but this is a real situation. Considering that the lack of data points measure, the lack of data points in the data set with the functional size measurement, we have two scenarios. Independently, if they are using functional size measurement or not, the organizations have a very few data. Okay, we have a very few data, or there is no data at all. I mean, very few data means they are collecting as a project management program information about the data, about the projects, about what is the name, what is the area where developed, maybe the cost, and so on. That it's all. Okay, but they don't collect some other variables. For example, what type of development is, if there are quality model related, life cycle of the software related, main program related. They are not collect some other data. And the other situation is they don't collect any kind of data for the projects. I mean, they develop, implement projects, but they don't collect data. The only situation they have is some information about software engineering, like some use cases, that some class diagrams and so on. Very technical information, but not information related to the project management or related to I mean, not related, but the information that could be used to generate estimation models. So, considering this, these situations we have been observed very often in the Mexican industry, and most of the time that we get close to one customer, they are one of these situations that we need to tackle. So we have been tackled we have been defined a way to tackle that. I'm going to try to explain here as a case study. The case study has these 5 steps. The first step is try to identify the projects. What it means to identify the projects? We need to identify what kind of projects we're going to tackle. For example, if we are using or we are focusing the web projects, okay, we can identify only projects in that sense. Or we are focusing in agile projects, or in waterfall projects, or in projects that use Java or whatever, okay? This is the first step, the identification of the projects. What is the focus? What is the sample that we need to solve or to tackle that? After the identification of the type of project, we need to collect information. The collect information is all the information available about the, as we mentioned, the first language, the first operating system, and so on and so on. After we have the identification of the projects and we collect the information, we make a functional size approximation. Why the functional size approximation? As we have been mentioned here, they understand that identify or generate data set is requires effort and cost. So if we are using approximation size, functional size approximation, sorry, we can reduce that cost. Okay. In fact, most of the database generated for the Software Metrics Association is based in the approximation and present a behavior similar to the ISBSG. So we do not need to measure precisely, because with the functional size approximation, we have been proved that we have equivalent behavior as other database like ISBSG that have been measured directly using distinct standards. So after we have the functional size, this is at this point we identify the projects, we collect information, and we measure the projects. So the number of projects at the beginning is here, and this fall down to that point. What means that at the beginning, if we identify all the projects and we need to collect information, not all the projects that were identified have all the information, so the number was reduced, and then we have to approximate size. Not all the people, not all the projects that we get information could be measured or approximate. So at this point, we have a database from the client, okay? We have a database belong to the client that represents a productivity for the client, a productivity model as mentioned by Albran to represent the productivity of the company that we are working for. But usually this database is with few data. So not enough in the statistical foundations to generate a good estimation model. However, we have also database in the ISBSG, and also we have data in the AMMS association. So the idea here is to try to integrate all these database to improve the number of data here, and then generate an estimation model. The case study that we are presenting here, I'm not going to show too much information about the first 3 steps. I will focus from the integration or a little bit before the integration of database to the final estimation model. So we have, that was how the case study was planned. So this is the application of this case study. We select one client, then we have identified 2 technical towers. They identify technical towers, they call like that. And the first one is APIs and microservices. The second technical tower is mainframe legacy. And the third one is web platforms. For the APIs and microservice, we get data from the client, the ISBSG, and the AMMS. We have data in the three database. For the mainframe legacy, we only have data for the client and the ISBSG. And for the web platforms, we have the client that do not have data. That is a very often situation in Mexico. Most of the, a lot of clients, most of them do not have data for a specific situation, or this situation applies when there is a new technology that they do not have data yet. So this is the third one. So for the first case study, APIs and microservices. The data collection and functional size approximation, the first step, we identify for this case study that the client provide 8 projects that could be measure or approximate, make the approximation size and collect all the information data. We get 15 projects for the ISBSG, and we get 34 projects for the Mexican database. No? So the total is 57 projects. That is better than 8 projects, or better than 15 or 34 independently. When we measure all, or we get all the functional size for all the projects, we get this information. The client is 2,418, and so on for the ISBSG and the national database, and the total of the functionality of the database is that. So of course, most of the information is the national database provided by the national database. But there is only the raw data. I mean, we consider here all the data that provided by the client, the ISBSG, and the national database. If we develop a PDR analysis, considering the PDR is product delivery rate, that is the inverse of productivity. There is only the productivity of PDR as a reference. I think that it's clear for most of the people. If not, we have here the information about it. And we see in the median that there is a variation in the APIs, especially for the ISBSG. Okay, so if we see the database, the separated databases, the client, we could observe this correlation, or this data set with the correlation function for the ISBSG and also for the national database. Okay, so we can observe at the beginning, at first glance, that the number or the functional size are very distinct. So the natural step is to integrate all the data in a single database. But if we do that, we can get this regression model, okay? Where we observe that have a coefficient, correlation coefficient of 62%. This is integrated in making the integration in all database, all the raw data for the 3 databases that we get previously. So the situation here is the 3 databases could be integrated considering statistical foundations only with the goal to get high number of data points. The integration makes sense and is valid. This is the main questions in this case study. I mean, the situation that we present previously is very often in Mexico. We have small databases, small data points, and maybe an incentive to get more data points is only integrate the databases. However, we are proposing here to make some situation to validate if they could be integrated. So to do that, we are proposing to use parametric test validation. We are proposing the Kruskal-Wallis test that is a non-parametric alternative to the one-way ANOVA test. The idea for here in a simplified mode, the Kruskal-Weill test only compares the medians, okay? The idea with the Kruskal-Weills is contrast whether the different samples are equidistributed and therefore belong to the same distribution. That is the idea. We try to identify if we can integrate these databases. And not only because with the goal to get more data. I mean, if we can integrate because seems like or they're going to act like will belong to the same distribution. So after the parametric test was developed by the SPSS version 25 in Spanish, obviously because we have been working in Mexico. So we define the null hypothesis like all the medians are similar, are the same or similar, and the alternative hypothesis like at least one of the medians are different. So when we execute the test in the SPSS, we get this information. Degree of freedom 2, because we have using 3 databases. So the number of projects are 57, and we could see the p-value, very, very low p-value. So considering this, the null hypothesis is rejected. So we can identify that at least one of the distribution database do not have a behavior or do not have the same median or do not is not equidistant like others. So after that, if we found this, we need to make the same test, but considering each pairs. For example, ISBSG with the national database, with the client database, and also the client with the national database. We observe here with the value, with the p-value, that the database, the national database and the client database could be integrated correctly. So we only have, or in this situation, we only can consider the national database, that means the Mexican database, and also the client database. After we integrate that only this database, we make a consideration of the outliers. The outliers are considering maybe using the 2K test, using interquartile distance, or using the standard deviation. No, the interquartile range, it could be 1.5 part to the right and to the left. They are considered outliers. For the standard deviation, there are two standard deviation for the left and for the right. After that, they are considered outliers. After do that, from the database integrated only with the Mexican database and the client database, we have 42 projects instead of 47. However, 42 projects could be considered enough because we are only considering one variable, in this case effort. Okay, so we identified 9 outliers. So our total database is 33 projects, and we could observe that this model we present a correlation coefficient about 62%, and with these steps we improve the estimation model with 81%. So the idea with this process defined here is to improve the estimation models and try to integrate database to improve that model. Of course, there is not only these steps. After we integrate this model, the new projects that were estimated with this project, of course, there will be integrated to the database, but this is happening after the projects are concluded. So the same situation we have for the case study 2, where mainframe legacy type of projects. Okay. in this situation, we observe that in the national database, we have no data. We only have data for the client and for the ISBSG. This is the total size of the databases. So the median is a little bit similar. So integrating all databases is this estimation model or this productivity model with a coefficient correlation coefficient about 78%. So considering this, we make the parametric test about that we have been mentioned before. So we have only 45 projects, and we identify a p-value higher than 0.05. So the null hypothesis is accepted, and these databases could be integrated in one database. So after we integrate, we made of course the outliers analysis, and we identified 10 outliers in this database. We work with 35 projects, and we improve from this model to this model. Okay, when we improve the correlation coefficient to 90%. So, of course, we're gonna get or we expect to get better results with this model. The last one is a case study number 3 when we are using web platforms. This situation, as we could see here, the client do not present any kind of projects. So we only have projects for the ISBSG and the national database. This is the total functional size. Then the analysis of the PDR or the median of the PDRs is, I mean, pretty similar. So integrating these databases, this is the first estimation model. Integrating the databases without making the parametric test. After we make the parametric test, we get that is a little bit higher from the 0.05 for the p-value, so we can accept that. I mean, that means that is almost couldn't be integrated, but in this time is could be integrated for considering the results of this database, because the null hypothesis is accepted. So after the analysis of the outliers, we take off 13 projects, and we get a total of 32 projects, and we observe the improvement of the model. In the last 2 case study, we have at the beginning only 2 databases, and the results were improved most because the takeoff of the outliers, because they can because the parametric test indicate that could be integrated the databases. So, but the main issue is not about the only make the outliers analysis. I mean, the proposed methodology here, or what we are using to tackle this situation, is to define steps to make the analysis or the foundation about to answer the question if the databases are able to be joined. And after that, to make the outlier analysis. Because another situation could be if we could make, or we make the outlier analysis before, and then we make the parametric test. So we are proposing this because we have been present a good results in the national industry. So the conclusion, The use of this proposed procedure has made it possible to improve the estimation models in the Mexican industry from the integration of different databases, considering statistical foundations to validate the integration of different data sources. What we are saying here is that we are using it. We are not only make a proposal. We have been used and we have been improved the estimation models. Also, this proposal enables the client with the small data to increase the database at the first step in the database generation, considering similar projects in distinct databases. We are using here only two databases, ISBSG and national database, but the analysis could be made with other databases. I mean, not only three. We are using now only with three databases, but of course could be developed in using other databases. Of course, there are other considerations and treatment of the databases. For example, databases with a wedge-shaped form. In this situation, most of the databases do not clearly present a wedge-shaped form, but in a lot of situations we have been observed this wedge-shaped form, and in this situation I recommend to see this paper that soon will be published by the Programming and Computer Software Journal. We developed there situation how to tackle the wedge-shaped form if it's interesting for you. So I think this is all that I have to share with you, and let me know if there are some questions or not. Thank you.
Thanks a lot, Francisco. It was very interesting to hear about your research about the estimation there. I'm working the same with IFA function point project, so it will be interesting to see what we will come up with. Let's see if we have any questions. We have just first of all, we have a comment from our friend Thomas Feldman in Switzerland, and he thank you and says a very good presentation with the valid statistical methods used. So if you have any questions, please put them in the chat now. Otherwise, you can always come with the questions later on, later today, and or send them to me. Here is one, just a quick question. How the process homogeneity is ensured while doing outlier analysis and integrating different databases points?
Yes, we have not developed the homogeneity. I mean, we are not focusing to analyze or to quantify or to evaluate the homogeneity, because I mean, in the practice, in the industry, we need a database. Okay, we need to solve the issue about the database. So we are trying to focus to generate this database, validating only if they have or they are equidistant from the median. So we are not move forward to evaluate all the statistical situation. This is the first step that only validate if the database could be integrated. But I see now for your question that could be further work that we need to develop in that.